So if we want to describe a vector in the xy plane, what do we do? Starting with a line on the plane, let's say I'm going to make it starting from the origin. Here is a line. I can then consider this line moving in this direction by whatever unit, and then moving in that direction by whatever unit. And if I'm to have this vector moving sideways by A and moving up by B units, I can consider this vector having equation AI plus BJ, where I and J are to describe the length, one unit going sideways or one unit going up. So I can have my vector expressed using the xy coordinate, whether it is, in this case, I have AI plus BJ, or in this case, I can express my vector in this way, and having I or J being the unit vectors to indicate the direction, in the x direction or the y direction. I can also calculate the length of this vector using the Pythagorean theorem. A squared plus b squared equals c squared. No, not a vector. C squared. So the length of this line would basically be this. So I can now calculate the length of a vector when they have the value of the vector given to us. You can also extend this idea into 3D, where you have I, J, and K to indicate the line going in the x direction, in the y direction, and in the z direction. For a vector to go in the z direction, you're talking about its height on your graph when the x and y axes are still on 2D, like on a plane. So in this example, let's say I have a vector with 2i minus or plus j, let's just keep everything positive, plus 3k, then I will see a vector that is 2 units away from the origin in the x direction, 1 unit away from the origin in the y direction, and using this as the base of your line, you are going to get to a point that is 3 units above the ground surface. So if I have a line going up this way in 3 units, starting from the point here, moving this line up by 3 units will give us a point there. Now of course, it doesn't look like a vector in 3D because it is difficult to draw a 3D shape or 3D graph on a piece of paper when you are only limited to 2 dimensions. But here, if I have the vector 2i plus 1j plus 3k, I will see a line going from the origin and get to this point here. That would be the vector in 3D. Now there are a few things that you need to know for vector. First of all, zero vector. It is to describe a vector with no length, with no direction. So you're talking about just a single point. Sometimes if you want to indicate the direction without making reference to its length, you may want to use unit vector. So that would take away the magnitude of your vector, simply to describe the direction of your vector. And you can come up with the direction of the vector and not using the length by dividing your vector with its length. So instead of using examples such as 2i plus 3j, let's say, I have a line in 2D, just make it simple, having a vector with 2i plus 3j, 2i plus 3j. I don't want to use a vector that has a length of 13. Then what I can do is to simply divide the I component and the j component by the length of the vector, which means I probably will have a line that is approximately this long with 1 unit long. This line is 1 unit long, giving us the same direction as the one that I create. Let me call this vector u, and this vector u will have the same direction as my unit vector, and the length of this unit vector will be a 1 when you use your Pythagorean theorem to check it. One last concept: when two vectors are multiple of each other, you can then come up with two vectors that are collinear. And you can actually see this happen in the example I just came up with. I have one vector going this way, the long one, the blue one, and I have another vector, shorter one, that goes in the same direction. And pretty obvious, this vector here is going in the same direction, and therefore it will give us we will describe these two vectors as collinear.